All right, let's look at this problem with this manometer shown. All right, the pressure is measured by the manometer. One of the arms is open to atmospheric pressure, where it tells us the local atmospheric pressure is 14.2 psi. They didn't tell us what the pressure was. We could assume standard atmospheric pressure, but it tells us that the pressure is 14.2 psi. Determine the absolute pressure in the pipeline. So this is the psi absolute. This is the absolute pressure right here. So now here everything is going to be an absolute pressure. All right. So you just kind of need to choose where you want to start, where you want to end, and you could do it either way. You could kind of go either direction from here and end up here, or start here. I'm going to start here since I know that. All right, so I'm going to start here, and I'm going to say, all right, I've got a pressure of 14.2 psi. All right, that A just means absolute. This is pounds per square inch. And then I'm going to go down here. All right, I'm going down 25. So I'm going to add, let me just say rho GH, because we're going to get into a mess with the units here. All right. And then I'm going to go, so you know, it didn't matter that I went down and back up. It just matters the height that you start, the height that you end at. So I went down by 27 inches. And so I'm adding because I'm going down. All right, here. Then I go here to here, but it doesn't matter that I went up. I'm going here to here. Now I could subtract rho GH of air, but we're going to assume that this is negligible. So I can go from here straight to here without doing any conversion. All right, but then I need to go from here down to here. So I'm going to add rho GH of mercury. All right, so here's water, here's mercury. Mercury has a specific gravity. We covered that in the notes. So it's 13.6 times the density of water. Specific gravity is relative to water, so it's 13.6 times the density of water. And then I will end up at the pressure of the gas, and that is what I'm looking for. That's what it's asking for. Determine the absolute pressure in this natural gas pipeline. Okay, so 14.2 plus rho GH of the water plus rho GH of the mercury, and I equal, you know, the pressure that I'm looking for. All right, so we're gonna have a mess with our units. We'll have that unit conversion sheet ready. This is 14.2 pound force per inch squared, because that's, you know, pressure is pounds per square inch, force per square inch. That's pound force, not pound mass, plus the density of water, GH of water, 27 inches. Let's go to our unit conversion sheet to get the density of water. I know the density of water is 1,000 kilogram per meter cubed, but that was in SI units. We're in English units. What is the density of water in English units? Go to our conversion factor sheet. The density of water, 62.4 pound mass per feet cubed, or 0.036127 pound mass per inch cubed. Do we want feet or inches? Right? Do we want feet or inches? Well, let's go back here. We want pounds per square inch. Also, our height is in inches. I think we want inches. Okay, so the density of water, let's see, what was it? Sorry. 0.036127. 0.036127. That was pound mass per inches cubed. Okay. Now, gravity, 32.2 feet per second squared. Oh, it's getting ugly with feet, inches. And then a height of 27 inches. Okay, I cannot just multiply those together and come out with the same units as pound force per inches squared. Okay, let me figure out this pound mass, okay? I've got pound mass here, and there are other ways to do this. You can look at some other YouTube channels, some other explanations. This is how I do it. I see pound mass, but I know I need pound force. I see pound mass, but I know I need pound force. Is there a unit conversion between pound mass and pound force? Yes, on our conversion sheet with forces right here. 1 pound force is 32.2 pound mass feet per second squared. Okay, so I'm just going to take this as a unit conversion right here and go here and say, okay, pound mass, pound force. I know that 1 pound force is equal to 32.2 pound mass feet per second squared. Alright, so that takes care of the pound mass is now pound force. That also took care of this feet, this feet per second with that feet per second, the feet per second squared with that feet per second squared. And that it worked. And so I'm left with pound force and inches cubed. So I'm pound force per inches squared. My units worked out. All right. So you probably have kind of saw that 32 cancels out with 32.2 here, but that's the way I'm going to do these problems. All right, is if I have pound mass in there and I want pound force, I'm going to divide it by 32.2 pound mass feet per second squared. 32.2 pound mass feet per second squared. Okay, I'm kind of taking the longer route, but that's the way I like to do it. That's the way it works for me. All right, so anyway, that was the rho GH. That was the rho GH for water. Now I need the rho GH as it goes through this mercury here. The rho of mercury is 13.6 times the density of water. All right, I'm not going to keep up with my units because I have the units same up here. So this is rho G, an H of 6 inches, and a conversion from pound force to pound mass right here of 32.2. All right, and that equals the pressure that I'm looking for. That equals the pressure that I'm looking for. So 14.2 plus this value, 18.1 psia. 18.1 psia is the pressure in the gas. Okay, so let's take a step back and look at what we did. We knew the pressure here, so we started here. We added rho GH to get down to here. We did not do anything to go from here to here because that was air. We're just going to neglect that. But then we subtracted added rho GH because we went down. When you go down deeper, you add rho GH to get to the gas in the pipeline. All right.